building for heat, sand, and silence. There are places where nature pushes its limits. The sun scorches, the wind bites, the air is dry and unforgiving. And the silence, it's almost tangible, as if it were a material in itself. This is the desert, one of the most demanding testing grounds for architecture. But it is precisely these challenges that inspire extraordinary solutions. In such a landscape, an architect doesn't simply build. They enter into a dialogue with the sun, the wind, and the absence of water. Shade is not a luxury, but a necessity. Every opening, every material, every thickness of a wall becomes a carefully crafted response to the language of nature. What emerges is not just a building, it's a survival strategy. In this video, we'll journey through some of the hottest, quietest, and most unforgiving regions on Earth. We'll explore how desert architecture has evolved over centuries, how ancient wisdom continues to shape modern design, and how architecture doesn't have to fight nature, it can exist in harmony with it. If you're ready, let's begin our journey into the world of structures that breathe quietly beneath the desert sun. Site planning and massing. Orientation to the sun. The north facade is preferred for openings since northern light is softer for the northern hemisphere. The south facade, exposed to high-angle sun in summer, is controlled using overhangs or brise-soleil. The east and west facades receive low-angle direct sunlight in the morning and evening, which increases heat gain. Therefore, desert architecture favors more closed or narrow openings on these facades. Compactness and mass density. The building's form is designed to be simple and dense to cope with harsh climatic conditions. Compact shapes like cubes and cylinders have less external surface area, making them advantageous for minimizing heat gain. Instead of complex, articulated forms, simple and consolidated volumes help establish a balanced relationship with the environment. Topography and terrain. On flat terrain, structures can be partially embedded or slightly elevated depending on design intent and climate conditions. Partially embedded volumes take advantage of the thermal stability of the earth to cool interiors and balance temperature fluctuations. Elevated structures enhance airflow beneath them, improving natural ventilation and contributing to the surrounding microclimate. Solid void balance. Courtyard concept. In desert architecture, buildings are often planned around a central courtyard, creating an inward-focused spatial organization that forms a protected inner world against harsh climate. The courtyard helps direct airflow, optimize shading, and establish a microclimate that improves thermal comfort indoors. Transitional spaces. Transitional spaces are a key component of massing, a sequence of enclosed interiors, semi-open transitional areas, REVAC. Iwan, open courtyard establishes both climatic and spatial flow. A REVAC is a covered but open-sided colonnaded walkway, providing continuity between interior and exterior. An Iwan is a deep, shaded space that is enclosed on three sides and open to the courtyard on one side, offering a cool, protective intermediate zone. Shading. The geometry of the building is shaped to cast its own shade. Deep recesses, projecting overhangs, and inset openings create dynamic shading along facades, controlling direct sunlight. Traditional elements like REVACs and Iwans act as semi-open shading spaces. In contemporary design, this approach is reinterpreted with perforated screens, sunshade panels, and dynamic facades. Integrated shading systems also contribute to energy management. They block direct sunlight to reduce cooling loads and create more uniform daylight conditions. Shaded areas around the building improve not only interior comfort, but also the exterior microclimate. High-angle southern sun can be controlled with horizontal overhangs, while low-angle morning and evening sun from the east and west is mitigated with vertical fins and reduced openings. Glazing. Glass must be used with care in desert climates due to its high thermal transmittance, which can cause overheating and increase cooling demands. Thus, Traditional and modern desert buildings minimize glazing and use it strategically. Rather than continuous views, desert architecture frames selected vistas through openings, offering controlled visual connections to the landscape. The glazing strategy also varies by facade orientation. The north facade allows larger openings due to soft, diffuse light. The south facade features carefully shaded openings with deep recesses to block summer sun while admitting winter warmth. The east and west facades have minimal openings to limit harsh, low-angle light, supplemented by vertical screens or perforated panels. A traditional solution is the placement of windows at higher elevations, which limits direct sunlight and supports natural ventilation through the stack effect as warm air rises. In modern desert architecture, these principles become more sophisticated. Some contemporary designs incorporate double facades with thermal buffer windows, where openings are set behind semi-open zones to manage heat and add visual depth. Optical comfort is also critical. Modern glazing often includes reflective coatings or tinted finishes to reduce glare and eye strain, addressing the phenomenon of desert glare that causes visual discomfort under intense sunlight. Materials and color selection. In desert architecture, material and color selection define not only aesthetics, but also thermal performance and environmental integration. Materials must be durable and climate responsive due to extreme temperatures, intense sunlight, and sandstorms. Traditional architecture emphasizes local, natural materials. Adobe, rammed earth, and stone provide high thermal mass, absorbing heat during the day and releasing it at night to regulate interior temperature. These materials are also breathable, helping to moderate indoor humidity. In modern desert architecture, traditional materials are combined with contemporary technologies. For example, rammed earth panels integrated with thermal insulation. Light-colored materials are preferred for their high solar reflectivity, reducing heat absorption on exterior surfaces. Earth tones like beige, light gray, and stone hues contribute both to heat control and visual harmony with the landscape. Natural ventilation. Even during extreme heat, desert buildings aim to cool interiors using natural airflow. Various strategies are employed to control air movement within the structure. Wind towers badger. Common in Iran and the Arabian Peninsula, these traditional devices face prevailing winds, channeling cool air down the tower while warm indoor air rises and exits, creating continuous airflow. Cross-ventilation. Openings positioned on opposite sides of interior spaces enable consistent air movement, flushing out hot air efficiently. Water and vegetation. In hot and arid environments, water features and vegetation are more than ornamental. They provide psychological relief and actively reduce ambient temperatures. Water elements are typically placed in courtyards or near semi-open spaces like revacs. Small reflecting pools and channels create cooling microclimates through surface evaporation, especially when airflow passes over them. Vegetation consists of carefully selected drought-tolerant species, cacti, succulents, desert lilies, and hardy trees like date palms or acacias. Plants offer shading, reduce ground temperature, and enhance the environmental comfort of outdoor spaces. In traditional settlements, water and vegetation work together. Trees and water features in courtyards create cool, protected living spaces. In modern desert architecture, this principle is supported by technologies such as rainwater harvesting and graywater reuse systems. Explanation of contemporary desert architecture. Hidden Valley Desert House, designed by Wendell Burnett Architects in the Arizona desert, exemplifies minimalist yet climate-responsive contemporary desert architecture. The project reinterprets traditional desert principles through modern materials, technologies, and spatial approaches. Site planning and massing. The structure adopts a low-profile, linear form that aligns with the natural contours of the terrain. Rather than dominating the landscape, it integrates with it. The house sits atop a low stone plinth, slightly elevated from the ground. This elevation protects against sandstorms. It also facilitates airflow beneath the structure, contributing to passive cooling. Large canopy and shading. The house's most striking feature is a broad steel canopy covering both interior and exterior spaces. It filters intense sunlight, casting shade over living areas. It reduces cooling loads through passive shading. The canopy's dark interior contrasts with its reflective underside, providing both thermal control and a refined aesthetic. Material use. The primary structure and facades are constructed from locally sourced schist shale stone, blending the building visually with its surroundings. The stone's high thermal mass stabilizes indoor temperatures by storing heat during the day and releasing it at night. Interior finishes combine concrete, stainless steel, and glass, creating a sophisticated balance between traditional and modern material palettes. Glazing and landscape dialogue. Openings are strategically positioned, not as continuous glass walls, but as curated frames oriented towards specific landscape features. This approach manages heat gain, provides visual privacy, establishes a deliberate, intimate relationship with the desert landscape. Interior-exterior continuity. The plan promotes seamless transitions between open, semi-open, and enclosed spaces. Interior rooms extend into shaded terraces beneath the canopy, reflecting the contemporary desert approach of being inward-focused yet harmoniously connected with nature. This project showcases how contemporary desert architecture can be respectful of nature, energy-efficient, simple, and harmoniously integrated with its environment. Thank you for watching. Don't forget to subscribe for more architectural content.